So this is a video on Vectors 2 tutorial. Okay, so it's Vectors 2 tutorial and BMQ question 2, right? We need to find the vector equation and the Cartesian equation of the line L1. Right? So what we need to do is very quickly, we just need to look at 2 plus lambda, 1 minus lambda, and 2 lambda minus 3. Right? So for BMQ 2a, it's rather simple. All you do is we just see 2 plus lambda. Right? So what I'm going to do, I'm going to put lambda at the side. I'm going to use it as a direction vector, and you can very easily, you know that if you need a vector equation, it's going to look something like it's like a fixed position vector plus lambda plus m, where m is a direction vector. Okay, so that means likely all the numbers here, like your m1, m2, m3, they need to be multiples of lambda, and all these, right, are like very likely they are all the constants. Okay, so we were to use our 2a, right? Our 2a looks like this lah. Our 2a looks so far is 2 plus lambda, 1 minus lambda, and 2 lambda minus 3. I'm just going to write it as negative 3 plus 2 lambda. You can see that if I were to split it into the constants and those who are scalars of a, right, I can write it in the following manner: plus lambda 1, negative 1, and 2. Okay, and very quickly, this would be the position vector that lies on R. This would be the direction vector of R. Okay, and this will give us the vector equation of line 1 for BMQ 2a. Alright, how about the Cartesian equation? For the Cartesian equation, right, what we can do is we make again, now instead of making, now we're making lambda the subject. Okay, so back to original equation, we recall that our x, this equals to 2 plus lambda. Right, our r is equals to x, y, z, right? So x, y, z is equals to 1 minus lambda. Z is equals to negative 3 plus 2 lambda. Alright, so all you need to do is we make lambda the subject. Okay, we always do this. We make lambda the subject to find the Cartesian equation. So Cartesian equation, remember Cartesian is in terms of x and y. Vector equation then be in terms of the vectors, right? The direction and the position vector. Right? So we make lambda the subject in order to find the Cartesian equation. So what do we do? X equals to 2 plus lambda. We can see that lambda equals to x minus 2. Right? Y will be equals to 1 minus lambda. We can see that lambda equals to 1 minus y. Okay? And z equals to 2 lambda minus 3. We can see that lambda equals to z plus 3 over 2. Okay? And from here, we can see that since lambda is equals to all 3, right? This also means that each of them are equal to each other. And lambda equals x minus 2 equals to 1 minus y equals to z plus 3 over 2. Okay, and with that, this would be in terms of x, y, z, and this is the Cartesian equation of BMQ 2a. Alright, what about 2b? Alright, we want to find the vector equation of the line 1 minus x over negative 2, y plus 1 over negative 3, and z equals to negative 1. Okay, from here, right, what you can do is very quickly we just we know that here this is actually a Cartesian equation because it's in terms of x, y, and z, right? So very quickly, let's write this out. We know that if you work backwards, you know that how we get a Cartesian equation is that we make lambda the subject. So we also can say that based on BMQ 2b, lambda is equals to 1 minus x over negative 2. This means that negative 2 lambda equals to 1 minus x, and x equals to 1 plus 2 lambda. Alright. Next, we know that lambda is equals to y plus 1 over negative 3. Negative 3 lambda minus 1 will be equals to y. We know that z is equals to negative 1. Okay, so this means that doesn't involve lambda at all. Right, so very quickly we can see x is equals to 1 plus 2 lambda. Y is equals to negative 1 minus 3 lambda. z is equals to -1, and from here we can quickly write out this will be the position vector. Lambda, this will become our direction vector, 0. Okay, so let me rewrite this. So x, y, z, which is r, is equals to 1, -1, 1 from here, plus lambda, and 2, -3, 0, where your lambda will just be any real number.